Hello everyone, this is the ICP4 Big Data Analytics. The goal is to do sentiment analysis on the deep learning classifier, and before I walk through the code, I will start the execution so as to show the execution over the demo. As you see, the code is now running. So the goal of this objective is that there is the first level we have to do the data cleaning with all these types of techniques and data processing, tokenization, stemming, lemmatization, parts of speech tagging, and sampling, text classification with deep learning classifier visualization, and giving out the prediction and accuracies and the plots to understand what it is. So going through the code, here I was reading the data frame, and here is the pre-processing. Pre-processing involves removing the Twitter handles, lowering the characters, and removing the special characters and the numbers which does not contribute to sentiment analysis or the NLP based techniques. So the second stage to processing is top for removal, tokenization, lemmatization, and I've stored these values, the tokenized values, lemmatized values, and stemmed values as different columns within the data frame, as you can see here. And going through that, now that POS tagging is also shown as different column in the same data set, as you can see here. Now I'm trying to understand what types of samples the data is. The data has a very imbalanced nature, wherein negative tweets are about 29,000 and positive tweets about 2,000, which is highly imbalanced. So I'm using two types of techniques as oversampling and undersampling to ensure the lower data is mimicked with the same types of data to push it up till 29,000 records to have between positive and negative same tweets. And so is the case with the undersampling to reduce the highest number of tweets to match to the lowest number of tweets, so that we could use that for the further training. And the demonstration of this program involves using the imbalanced data, oversampled data, and undersampled data, putting through the deep learning classifier and see how these different variations of these data perform with both one coding and the compact embedding based techniques for the words to vector conversations. And also the demonstration involves comparison of these values with the old machine learning values that we had. As you can see, I've used deep learning classifiers. Here is what just I'm reading the values of features and the targets of the three different types. One is the normal ones, one is the oversample data, and the undersample data. And this is a bit of explanation of what one hot encoding and the embedding layers in Keras is. Balanced data, I'm going through the one hot encoding and the embedding based techniques. As you can see, I've used 20 epochs for this to run, and as you can see the history plots, the validation accuracy starts from 93%, 94%, and the training accuracy starts from 93%. And as we can see in the graph, that has significantly improved with number of epochs that's been passed. Finally, it's more or less stabilized around this area, 10 epochs. But then as you see, the model is not overfitted. As we can see, the data of prediction is going straight. It doesn't decrease with the types of data that we are going through. As we can see in the embedding technique, we see a slight overfit of the model. As we see, while even though accuracy was as high as 99% for the training, but the validation, as you can see, is slowly going down the hill. So it's 94.78 from 94.89 in the before epoch, which means there is a slightly possible case of this going on the significant lower side as overfitting type of technique, which we could avoid with using dropout values or the other approaches. Now going with the oversampled data, as we can see, this is still getting trained, but we can see already the accuracy is hitting as high as 99.51 and the validation accuracy was about 98.76. I've run this before and I've collected the results already, and I'll show the results by the time the completion of the runs would happen. As you can see, the oversample data for the machine learning has resulted in test accuracy about 94%, 0.5, and which is the highest, and the imbalance was about 94.14, which is a medium, and the undersample is the lowest. The same application with deep learning classifiers, if I'm using one hot encoding, you can see the oversample data training accuracy is as high as 99.56, but training test accuracy is as high as 98.78, the highest of all. And the imbalance data, the training accuracy is about 99.71 and 95.79 for the test accuracy. And the same is the case with undersample. Undersample has shown very bad test accuracy because of the imbalance between the types of data that we have and very less samples of the data. We hardly trained the classifier with about 4,000 samples, as we have undersampled it, and which clearly shows the fact machine learning is best when it has more data to solve. Now, going back to the graphs that's being generated, talking of the oversampled approaches with one hot encoding, as you can see, the accuracy is 99.50, is very high in terms of training accuracy, and the validation accuracy is equally high, 98.80, which is better from the training that I've received last time. As you can see, now this is the embedding based technique, and you can see the classifiers performing at 99.42 and 98.13 for testing accuracy. The undersample data is very less, so the training doesn't take a lot of time, but the validation accuracy is equally impacted because the number of samples that we trained with this is very less. As you can see, these are the graphs. So in short, the deductions are basically machine learning requires lots of data to show promising results in terms of predictions, and the oversample data so is the winner in basis of my hypothesis and the proved perspective. And the deep learning has got the highest accuracy. In this training, in this run, it has about 98.80, which is better than the last one, the last time I've trained it. And thank you.